So now we jump to the next level. Okay? This one that we just did, right, was a little bit advanced because it had a fraction. And it involved rationalizing your radicals and working with your radicals and doing that. Okay? What does the next level look like? The next level says, and we'll do it right beside, could you do this and solve for x if there was any number in front? Okay, we just did it with 3 minus 12 and 5. Okay, if we changed it to 6 minus 13 and 8, could we do it? Could we do it with any number? And in mathematics, when we try to do something with any number, we go to variables. So instead of doing 3x squared minus 12x plus 5 equals 0, we say we're going to try to do this with any number in front of x, so we'll call it a. Any number in front of the x, so we'll call it b, and any number by itself, we'll call it c. And if we can do this way, we can make a formula that always works. So the reason I'm doing this right beside is because we're going to think about what did we do with regular numbers, and could we do it if we had letters instead of regular numbers? First of all, we didn't like the 3 in front. So in this one, which one are we not liking in front? The a. What did we do to get rid of the 3? Divided everything by 3. What would we need to do to get rid of the a? Divide everything by a. So I would get just x squared, but this divided by a would be b over a, and c divided by a would be c over a, and it's okay that they're fractions, because we know how to work with fractions. Next step, oh, I should write them simultaneously at the same places. Next step, we move the 5/3 over to the other side. So we can do that here. I'm going to have x squared plus b over ax, and then I'm going to move the c over a to the other side. And I made spaces. And the next step, I wanted something squared. Okay? What did I use? I used the 4 as my hint. The 4 as my hint gave me 2. How did we go from the hint to the number here? We took this number and divided it by 2. So what would happen if I divided that by 2? I would get, same as multiplying the bottom by 2, or multiplying by half, I would get b over 2a if I took this and divided it by 2. How did I fill in this space and get the plus 4? I multiplied this out, right? And I always had to square this. So can you see that you would have a b squared over 4a squared there? And so if I add that to that side, I have to add b squared over 4a squared there. Equals. I have 2 fractions here. I had 2 fractions here. What did I have to do? I needed a common denominator to add them. Can you see that the common denominator would be 4a squared? And I would have to multiply this one by 4a and 4a to get that 4a squared. So I would get a negative 4ac plus b squared in my numerator. We did all that to get something squared, so we could square root both sides. So when I square root both sides, this side will just become x plus b over 2a, and this side will have a plus or minus square root. And just getting us really ready for the formula, can you see if you're adding 2 things, the order doesn't matter? So I'm going to write the b squared first because it's positive, over, and I'm going to write the square root on the bottom of 4a squared. actually simplifies really nicely on this side. On the bottom, top is going to stay b squared minus 4ac, but you can simplify the square root on the bottom. Because what's the square root of 4? 2. What's the square root of a squared? Just a. So where we had to rationalize on this one, on this side it actually works out. We don't even have to rationalize, which is really nice. Finally, if I want to get x by itself, I would have to subtract this onto the other side. So I'd have negative b over 2a plus or minus b squared minus 4ac over 2a. I have a common denominator for adding my fractions. And what we got right there is one of the most famous formulas you learn in high school math. Right? If I think about famous formulas you've learned, like a squared plus b squared equals c squared, pretty famous. Like there's area of square, area of circle. I don't think that they're that. I wouldn't say they're that famous because they're just like, oh, area of circle. Like the other one is like Pythagorean theorem. It's like fancy name. This one is called the quadratic formula. And what it allows you to do is you can now, with this formula, start with a question up here. Skip all the completing the square steps and get to an answer immediately. You see how powerful that would be? Because all I need to do is I need to plug in numbers. Like the b was whatever was, look at where we started. The b is whatever was in front of the x. The a is whatever was in front of the x squared, and the c is whatever was by itself. If you start it looking like this, you can plug it in. Now, I'm going to say that sometimes the completing the square will still be faster. But lots of times, being able to plug it into the formula will be faster. There's pros and cons to both, and we'll see. I can give you some examples. This one, I definitely would use the formula, just because, like, oh, I have to work with fractions. Makes it a little bit more work. Why not go to my formula right away? Let's, just for fun, I'm going to show you how the formula would have worked. We know this is the answer to the one that we just got. We are now going to take that one, which was 3x squared minus 12x plus 5 equals 0, and use the formula. Did I get all my numbers right? Yes. So according to the formula, I would go x is equal. My b value is negative 12, and here I would have negative b. Can you see negative 12 would be positive 12. Plus or minus square root b squared, negative 12 squared is positive 144, minus 4, a is 3, c is 5, over 2 times a. So I'm going to simplify inside that square root. 12 plus or minus the square root of 20, 60, 84 over 6. Okay? Now I'm going to scroll up just a little bit. Do you notice they're not the same? And this is where the quadratic formula sometimes has a little bit extra work. This answer and this answer should be identical. But they're not the same yet because we have to simplify this. Square root of 84 can be simplified. I hope you can see that that's 4 times 21. So if that's 4 times 21, I know that square root of 4 is 2. This will be 12 plus or minus 2 root 21 over 6. And then we have to see, is there a common factor you could pull out of everything? Right? And I'm going to do that right off to the side. Do you see that there's a 2 in each? There's 3 terms. 1 on the bottom, 2 on the top. And in all 3 of those terms is the factor of 2. So you could pull a 2 out of the top, leaving you with 6 plus or minus root 21. And you could pull a 2 out of the bottom to make it 2 times 3. And then the 2's, 2 divided by 2 is 1, so they would cancel out. And now our final answer matches our completing the square. So the quadratic formula got us the answer very quick, but we had to do work simplifying. Completing the square got us the answer slowly, but we didn't have to do as much work simplifying. So there's pros and cons to both of them. Quadratic formula is on your formula sheet. It's listed at the bottom of page 213. Take out our highlighter, or maybe not. No, highlighting choices are bad ideas. Oh, here we go. Take out our quadratic formula. There it is. Got it. So we're going to try to figure out, maybe determine which ones are nice ones to do with completing the square, which ones are nice ones to do with the quadratic formula. And some of them might work nicely with both. Okay? We also have to keep in the back of our head that we also learned the zero product property for factoring. So if you can factor, that is by far the best way to solve these questions. And so, when you get a solve an equation on a quiz or a test, you have to have in your brain that there are 3 ways that we've solved. Factoring is the fastest, but it doesn't always work. Completing the square and quadratic formula, both will always work. One of them's nice because it's a formula, and you don't have to do a lot of work to get there, but sometimes needs to be simplified. And the other one is nice because sometimes you don't have to worry much about simplifying. Okay, so here's our examples off to the side. Well, they're actually both nice. I like the ones, they're both nice with, I'm going to replace the second one with their second one. X squared minus x, their second one, plus 4. I replaced it because I actually think that part A is better with completing the square, and part B is better with the quadratic formula. And I'll show you why. Okay? I'll solve them both with both methods, and then you can decide why you might like one over the other. So, part A, with completing the square. We would take our x squared plus 2x, move the 7 over. The hint is the 2. Really easy to see that this would be, a 1. Oh, actually this is interesting in a whole different reason. Okay? I might even add another 1 to our example, because this one has something interesting happening. Okay, so you see that there would be a space here and a space here. we would go plus 1 in this space, so I have to go plus 1 in this space, giving me negative 6 on this side. And now that we've got something squared, we would have to square root both sides. And I would get x plus 1 equals plus or minus the square root of negative 6. And at this moment, you see a square root. This equation is easy because we get the square root of negative 6 right away. That's not possible. You can, as soon as you get the square root of a negative, you don't have to do more math. It's like get out jail free card. It's like, woohoo, not possible. And then you're done your work from there. With the quadratic formula, and we'll do that quadratic formula right here beside, we would have x equals negative b. That would be the number in front of the x, so it would be negative 2. I'm just going to write here using the quadratic formula. Can you see that a is 1, b is 2, and c is 7? Okay? So negative 2 plus or minus square root b squared would be 4 minus 4 times a, which is 1, times 7, over 2 times 1, which is 2. Simplifying this, you get negative 2 plus or minus, and in here you would get negative 24 over 2. And at this moment, you're like, get out of jail card free. Got a negative inside my square root. That's how my quadratic formula would tell me it's not possible. Okay. I will do one in between before I get this. So the B question that we're going to do is very similar. I think this might be the B question. That's actually, no, it's not quite. We can do the B question that's actually there. That way. I hope you could see that. Was it about the same amount of work with completing the square or the formula to find out this one was not possible? It's relatively the same. Okay? Second one, x squared minus 2x minus 7. Complete. So let's do the completing the square method first. So this is nice because it kind of gives us a chance to review what we learned yesterday. I would move the 7 over to the other side. I know that I want x plus something squared. The 2 is my hint. If I have a minus 2, can you see that you would need a minus 1? And then, if there's a minus 1 times a minus 1 would mean in this space I would have plus 1. If I add 1 to this side, I add 1 to this side, giving me 8. So I wanted to do this example because when we square root both sides, don't forget our plus or minus, it works out. Works out nicely because it's not a negative number in our square root. How would I get x by itself? I would have to move the 1 over to the other side, so I'm going to add 1 to both sides, plus or minus, and the square root of 8 can be simplified because it's part of our root 2 family. It's going to be 2 root 2. That's completing the square. Scroll up just to there. In the quadratic formula, can you see that your A value is 1, your B value is negative 2, and your C value is negative 7? So we plug things into the formula. Negative B would be negative 2, positive 2, plus or minus square root of B squared. Negative 2 squared is positive 4. Minus 4, A is 1, C is negative 7, over 2 times a, which will be 2. And we get x equals 2 plus or minus the square root of 32, all divided by 2. So with the quadratic formula, you're going to often have to simplify your square roots. So in this case, I see the square root of 32. I recognize that that's part of my root 2 family, because it's 16 times 2 is 32. So this becomes 2 plus or minus square root of 16 is 4, root 2 over 2. Is there a common factor in all three? 2. So one of the things you can start to do, if there's a common factor in every term, you can divide every term by 2. If I divide every term by 2, can you see that this will become a 1? Plus or minus, this will become a 2 root 2. And the bottom term, when you divide by 2, becomes a 1. You could write over 1, but you don't need to. This would be done. So we get the same answer. In this one, I kind of like the completing the square because we don't have to worry about simplifying a radical and all the factoring simplification. But relatively about the same amount of work. But this time I saw the other side as a little bit easier. When would I use the quadratic formula over completing the square? And that's why I wanted to do this. I'll do it cx squared minus x plus 4. If we did the completing the square method, starts off okay, but we are going to get a fraction, which isn't bad. But fractions mean that you're going to have a little bit more thinking work. Can you see the hint is a minus 1? So if the hint is a minus 1, we would have a minus half inside. And if I have a minus a half inside, when I go a half times a half, I would get plus a quarter here, plus a quarter there. Okay? How do I add fractions? Well, this will be common denominator. 16 over 4 plus 1 over 4 would give me 17 over 4. Now I can square root both sides. Square root of the top is 17. Square root of the bottom is nicely 2. Yes?
Isn't that supposed to be a negative 4?
Yes, it is supposed to be a negative 4. Thank you, because otherwise we would be screwed up royally. And we get another one. You would like the positive 4, because the positive 4 would make a negative 4 on the other side, and then we'd have another one of the get out of jail free ones, where you could just say not possible. Thank you for noticing that. So x squared minus x minus 4. That's what I want. And finally, now we can get x by itself by adding a half to both sides. Nicely, we already have a common denominator. So we get 1 plus or minus the square root of 17 over 2. Next, we'll do the quadratic formula. We know that A is equal to 1, B is equal to negative 1, and C is equal to negative 4. Negative B would be 1, plus or minus B squared would be 1 minus 4 times A times C divided by 2A. Woo! That one worked out really good with the formula. Nothing to simplify. Everything came out really nicely as an answer right away. So sometimes if you notice that completing the square is going to involve a lot of fractions, you're probably more tempted with the quadratic formula. If you notice the original equation does not have fractions and the completing the square is going to be relatively straightforward, you might prefer that method. All right. Please circle 4, 5, and 6. And we are going to do example 2 right away.